Hello guys, welcome to another video. This video I'm going to be participating in LeetCode's weekly contest 390. So yeah, it's going to begin in a few seconds and let's just get to it. um, Maximum length subject contains at most two occurrences of each character. So we will just brute force this. So if CNT of A two occurrences. So let's do it like this. And okay, or two, so yeah, that'll work. Hmm. Nums equals 1. Choose any, duplicate any element in the array and add it. Isn't this like, okay, so K is, so we can simulate it. It's the best strategy. So if, is there a faster strategy than just, so if it's 2, right, I just duplicate. If it's 3, how, if it's 3, can I do it under, in 2 operations? If it's 4, I'm trying to prove this strat is optimal. Because we definitely want to just um now if I okay, so if like the 4 and 2, so 3. So if I have like 3 ones and 3 twos, so the sum 1 1 1 2. So it's always better, I think. So it's just I minus 1 plus And how many times I need to. So like K something. So increase the first element up to I, and then so if I is equal to 2, 1 and 2. So 1. So this is 0. This is a rounded up division. Okay, how's that? So we have 4. So 3, 3 plus 4, 3 times. So minus 1. This is actually correct. So if I think I just want to make sure this. So increase it up to I. We find out how many times. Yeah. Okay. Frequency of IDs in the collection. Each element in nums represents an ID. Corresponding element ID should be added or removed. It means frequency. Okay, so step 0, we add 3 IDs, value 2. Two IDs, value 3. So, can't we just simulate it then? So we just simulate it. No? So if freak of I is bigger than 0, CNT of freak of I, frequency of I. You know what? This should be fine. Frequency of I. You know what? Screw, I'm just gonna be safe with a map. CNT nums I plus sigma. Freak of I. So like, yeah, we just do that and then oh, okay. So we just do that. So we just say answer and then answer of I. So if CNT dot CNT dot size answer of I is equals CNTR begin, right? Answer it. Count of the most frequent ID. I guess we want buckets, right? So we still want map, but now we want to count. If the bucket of nums of I is equal to 0, then just do CNT num. Well, so if it's like the count number is if freak of I is equals CNT nums of I, then we delete it. So we say wait, no. Bucket of Yeah, okay. If it's zero, then put it at the frequency. Mhm. Else, so if bucket is empty numbers of I minus minus, okay. With zero, it's fine. Okay. I think it's okay. 3, 3. Three, 3, 2, 2. Wrong answer? Oh, I actually got wrong answer. Shoot, that's gonna hurt quite a bit. Dang it. Got you. Oh my lord. Doing so bad. So bad. Oh my gosh. That just costed me 10 minutes. I forgot the actual frequency itself is long, long. Gosh dang it. Okay. That's the longest common prefix. Longest common suffix. That's gonna be a pain. Hmm. Okay, so CD. Hmm. Hmm. I guess I just like so I build a try of the strings in reverse. Then I just so I just build it. Okay. Return index of a string. Well, I'm still salty about this. Hmm. Because always guarantee the answer. So I have to build this try now, which is interesting. Chelsea going through it, and then if words answer that size is bigger than Hmm. Right. FCD. Hmm. Why is this taking me so long? 111,202. And I make sure I set the root right. I did. What the frick? Ah, are you for real? How's that even possible? How do you get memory limit exceeded with this? Sum of words. What? Hmm. Does this pass? Okay. Okay. That was some retarded thing. Okay, that was just bad by LeetCode. Like, how does that even doesn't make sense to get memory limit exceeded? But now that I finish the contest, I'll go over the problem. so, so here, basically, to find maximum length substring, two occurrences of each character. So what we can do is you can just brute force all possible substrings. So I have a cubic solution. So I have all of n squared from the different starting and indices of substrings, and I go through it, the substring again to count the characters. And I make sure for all the characters it has less or equal to 2 because that's the condition it wants. Then update our maximum answer with that. So this is just a brute force. This one is kind of tricky for me to explain what the optimal strategy is. Well, it is relatively simple, but the proof is I guess I'll try to come up with a proof. So basically, the best strategy is for you to increase your first number until x, and then you want to double as much as you need. So the thing is, you want to you want to try all the x's before you keep doubling it or duplicating it, I should say. So what I have here is so we have I minus 1. So this is increase first element to I, and then this crap plus I divided by 1 minus 1 divided by I number rounded up number of times I appears D equals a value such that I times D bigger equal to K. So we do round up division with this and then -1 because we already have elements. So that's basically this math thing. And the reason why this is optimal is because let's say you do 4 operations, right? So what can you do in 4 operations? You can do 1, 1, 1, 1, 1, 1, 1, right? So that's 4 operations. You could do 1, so 1, 1, 1, and then you change this to 2. So you basically like, and then you could do 1, 3, right? Because you increment this and you increment this 2 times. Or you can just do 4. You can do 5, right? Or you can also do 1, 4. So this is what you can do, right? The idea is that for the proof, you want to increase, well, no, you want to duplicate the maximum elements. So, like, all of these operations you do, you get the same sum. But the biggest element happens when you just increase the first one. Like, if you, like, I don't know, you just have a few more operations. Let's just say this is, just close this. So we compare this to, like, 5, right? So if I do this, so that's another operation, and I duplicate it too. I always get a better outcome when I do this, and then I do this, right? So you just want to, you don't want your sum to be so spread out. You want it to be just one number, so that for future operations, you just keep duplicating that biggest number. You always want to increase the first number before you duplicate it. Because, like, you can see, like, when I duplicate this is a much lower sum simply because the maximum L1 is lower. So I know that's not very formal, but that's the way I thought about it. So I spent like a good few minutes trying to make sure that this is optimal strategy. It's kind of nice that they kind of explained it in the example. I don't think they have any better strategy than this, to be honest. So that's problem 2. Problem 3 is just simulating it. So, of course, the problem is every step you have to somehow get the frequency of the most frequent ID. So what I did was I kind of did a like a bucket thing. So this count helps me keep track of the count of each individual frequency, and then I have a bucket that says how many things have this frequency. So since I use a map, I can just get the biggest entry in the map, which will give me the biggest frequency, and then it's just simulating the process and updating everything. So yeah, just so every time we add a new element, we like, I believe I can just merge this into one. Something like this. I think I can just merge this into one. Well, no, I'm not gonna do it. Just to keep things simple. But yeah. Let's say this first step, I So whatever frequency we have for this ID, I move it out of this bucket because I'm increasing its frequency, so it doesn't belong in this frequency bucket anymore. So you can see then it belongs in this new frequency, which is what we already had, and how many times you increase it. And then the same thing happens when you decrease it. So I just have to make sure that whenever frequency bucket is 0, I erase it so that when I do this, then I don't try to count frequency of nothing, highest frequency of nothing, which I got one wrong answer for. Well, yeah, the second one was me not using long, which I don't know why I made a mistake, but yeah. I guess I thought, well, I forgot about frequency being over the limit and such. So yeah, that's the third problem. The fourth problem, basically what I did was I built a try. So since we're querying suffixes, right? So each query, we want to find a suffix. So what we can do is we can reverse everything and just work with that. So then we can just, well, we technically insert the suffix in because we go through the words in reverse. So in each node, I keep track of the answer. So this part, I just insert them into try and I just do this. I probably don't even need these 2 lines. But anyways, so yeah, so I reverse so that I'm traversing suffixes so that like if I have this query CD, right, we'll go D and C, and these words will be in reverse order. So if I insert this, it will be DCB. So that way, this D is traversed, C is traversed, so we'll be able to find this BCD. And this is a part where I go through the words again and I've updated the answer. So this is literally the answer for each try node. So then I just compare the sizes and then compare the positions and update as necessary. And I go through each queries. I just try to go as far as I can in the try, and then I get the answers. Now apparently, I had this, and this gave me memory limit exceeded. I have no idea why, but I just changed it to a raw array and it works. Maybe there's some better approach, because I do realize the memory limit is 500,000. So maybe there's a better solution. I don't know. I just don't understand why vector would cause memory limit exceeded. Like, I get it's a tad bit bigger, realistically, but like, it should not be that this factor between getting wrong answer slash memory limit and accepted. So yeah, that's entire contest. See you guys.